Hello everyone, the main goal of this video is to make you learn a bit more about electrochemistry. First I am going to tell you about the history of electrochemistry, then Alexia will present you the working of the battery, and finally Esma will show you the experiment of the lemon battery. So electrochemistry is a branch of chemistry that studies chemical reactions which take place in a solution at the interface of an electron conductor, a metal or a semiconductor, and a unique conductor, the electrolyte, and which involve electron transfer between the electrode and the electrolyte or species in solution. If a chemical reaction is driven by an external applied voltage, as in electrolysis, or if a voltage is created by a chemical reaction, as in battery, it is an electrochemical reaction. In general, electrochemistry deals with situations where oxidation and reduction reactions are separated in space or time, connected by an external electric circuit to understand each process. English chemists John Daniell and Michael Faraday are both considered as founders of electrochemistry today. Understanding of electrical matters began in the 16th century. During this century, the English scientist William Gilbert spent 17 years experimenting with magnetism and became known as the father of magnetism. In 1663, the German physicist Otto von Guericke created the first electric generator which produced static electricity by applying friction in the machine. Charles-Augustin de Coulomb developed the law of electrostatic attraction in 1785 as an outgrowth of his attempt to investigate the law of electrical repulsions as stated by Joseph Priestley in England. In the early 19th century, Italian physicist Alessandro Volta showed his battery to French Emperor Napoleon Bonaparte. Sir Humphrey Davy's work with electrolysis led to the conclusion that the production of electricity in simple electrolytic cells resulted from chemical action and that chemical combination occurred between substances of opposite charge. In 1827, the German scientist Georg Ohm expressed his law in his famous book in which he gave his complete theory of electricity. In 1832, Michael Faraday's experiments led him to state his two laws of electrochemistry. Svante Arrhenius published in his thesis in 1884 on Recherche sur la conductibilité galvanique des électrolytes. From his results, the author concluded that electrolytes, when dissolved in water, become to varying degrees split or dissociated into electrically opposite positive and negative ions. Walter Hermann Nernst developed the theory of the electromotive force of the voltaic cell in 1888. In 1889, he showed how the characteristics of the current produced could be used to calculate the free energy change in the chemical reaction producing the current. He constructed an equation known as Nernst equation, which related the voltage of a cell to its properties.
An electrochemical cell is a device capable of either deriving electrical energy from chemical reactions or facilitating chemical reaction through the introduction of electrical energy. An electrochemical cell consists of two half cells. Each half cell consists of a conductive electrode and an electrolyte. Electrodes can be made from any sufficiently conductive materials such as metals, semiconductors, graphite, and even conductive polymers, whereas the electrolytes contains ions that can freely move. The chemical reactions in the cell may involve the electrolyte and the electrodes. In a full electrochemical cell, species from one half of the cell lose electrons to their electrode, while species from the other half cell gain electrons from their electrode. The anode is defined as the electrode where oxidation occurs, and the cathode is the electrode where the reduction takes place. A salt bridge is often employed to provide ionic contacts between two half cells with different electrolytes to prevent the solutions from mixing and causing unwanted side reactions. A battery is a number of cells combined, and it is used to supply electrical energy that is stored chemically. The term battery is often and incorrectly used to describe a single cell. In a battery, cells are usually wired in series to increase the supply voltage, but sometimes wired is parallel to allow greater current to be supplied. Batteries are optimized to produce a constant electric current for as long as possible. Dry cells, for example, this kind of dry cells, do not have a fluid electrolyte. Instead, they use a moist electrolyte paste. Lenche's cell is a good example of this, where the anode is a zinc container surrounded by a thin layer of manganese dioxide and a moist electrolyte paste of ammonium chloride and zinc chloride mixed. The cell's cathode is represented by a carbon bar inserted on the cell's electrolyte, usually placed in the middle. The voltage obtained from the zinc-carbon battery is around 150 volts. The mercury battery first appeared in the early 1940s. The mercury battery has many applications in medicine and electronics, for example in watches. The battery consists of a steel-made container in the shape of a cylinder, acting as a cathode, where an amalgamated anode of mercury and zinc is surrounded by a stronger alkaline electrolyte and a paste of zinc oxide and mercury oxide. Such batteries provide 35 volts of direct current. We also have lead acid battery. The lead acid battery is used in automobile. It consists of a series of 6 identical cells assembled in series. Each cell has a lead anode and cathode made from lead dioxide packed in a metal plaque. Cathode and anode are submerged in a solution of sulfuric acid, acting as the electrolyte. Differing from mercury and zinc carbon batteries, lead acid batteries are rechargeable. If an external voltage is supplied to the battery, it will produce an electrolysis of the products in the overall reaction, thus recovering initial components which made the battery work. The last battery I will show you is a lithium rechargeable battery, as you have in your laptop or in your digital camera. Instead of an aqueous electrolyte or moist electrolyte paste, a solid-state battery operates using a solid electrolyte. Lithium polymer batteries are an example of this. A graphite bar acts at the anode, a bar of lithium cobaltate acts at the cathode, and a polymer swollen with a lithium salt allows the passage of ions and serves as the electrolyte. Lithium-ion battery technologies are widely used in portable electronics devices because they have high energy, storage density, and are rechargeable. These technologies showed
promise for future automotive applications with new materials such as iron phosphates and lithium. Prevention of corrosion is one of the main uses of electrochemistry in industry. While it is almost impossible to prevent the formation of corrosion, there are two types to save metal from corrosion. If a non-conducting metal covers the metal, contact with the electrolyte is not possible and corrosion will not occur. First, a metal can be coated with paint or other less conductive metals which provokes a reaction of passivation. This prevents the metal surface from being exposed to electrolytes. Scratches exposing the metal substrate will result in corrosion. There are also sacrificial anodes, which is a method commonly used to protect a structural metal. The principle is to attach a metal which is more anodic than the metal to be protected. It is called sacrificial because the anode dissolves and has to be replaced periodically.
The device used in experiments concerning electrochemistry. It is made by inserting two metallic different objects as electrodes, for example a galvanized nail and a copper coil. Here we use as electrodes an electrode of zinc which serves as the anode, and the copper wire which serves as the cathode. We can see that if we put the copper wire inside the lumen and also the electrode of the zinc inside the lumen, a change in the intensity in the ampere it is a fact of redox reaction that can be illustrated in this schema. Indeed, the oxidation of the zinc is located in the anode, and the reduction of the hydrogen ions which come from the acidic solution at the cathode. This source comes from the chemical change in the zinc, which is oxidized inside the lumen thanks to an exchange of some of its electrons in order to reach a lower energy. The electric current comes from the movement of the electrons from the negative electrode towards the positive electrode. So this lumen battery produces not enough electric current to light a bulb. Nevertheless, because of the high rate of acidity, lemons are preferred to potatoes in electrochemical reaction, whereas electrolyte is phosphoric acid, and indeed in the phosphoric acid there are less acidity than in citric acid. So we prefer to use Lehman's battery in this kind of experiments.
I just don't care about the evening news. I never listen to the crack house blues. They say the city is the place to be. I wanna dance with